You're a developer. You are a developer. And that's pretty cool. But why is that cool? Well, it's cool because developers write code. And code is cool, right? Okay, but why is code cool? Well, code is cool because when you write great code, you build great applications. Applications that delight your users, that make their lives easier and more fun and more efficient and safer. And now that is really cool. But you know what's not cool? What's not cool is once you've written this great code, worrying about how you can deploy it so that it can serve millions of users around the world. Or worrying about, once you've built a great front end, how you communicate with the back end. Or worrying about, once you've built your application, how you test it so that it works on different browsers and different mobile devices. None of that is cool. Well, that's why we are here today. We want to show you how you can use AWS to build, to host, and to test an application easily, allowing you to focus on what makes you cool: writing great code. I'm here with Ozzy. My name's Fred. We are both specialists here at AWS in the front-end web and mobile development area, and we cannot wait to take you on this journey today. So let's get started. And before we get started, I think it's worth looking at a bit of the context that we have been observing here at AWS. Some of the trends that we're seeing in the developer world. Because what we have noticed is that front-end developers are increasingly taking on some of the responsibilities of a full-stack developer. And what does that actually mean in detail? So if we look here at our typical full-stack application, we've got our front end on the right and our back end on the left. And while a front-end developer is traditionally looking at those core building blocks on the front end, like HTML, like CSS, like JavaScript, and some of the frameworks that we have seen emerge over the last 10, 15 years, on the other end, we have the responsibilities of the backend. So we have the database where the data is actually persisted, and we have the servers where the code that you're writing is actually run. And while traditionally we might have had entire teams who focused on managing those infrastructure components, with the advancement in technology that we're seeing, things like NoSQL databases, things like serverless compute in the form of AWS Lambda, a lot of those teams no longer have to focus on that undifferentiated heavy lifting. And while that's great for front-end developers because they're now more involved in the cloud decisions of their companies, it also adds a lot of complexity because those developers have to be more aware of how those back-end components function in conjunction with their front-end code. And that adds a lot of complexity, right? And we'll talk today about how we can address some of that complexity on AWS. But first, I want you to come on a little journey with me. I want you to imagine that you're a developer, and it's Monday morning, and you're sitting down at your desk, and you're feeling great. You've got all your priorities for the week listed. You know exactly what you're doing. Your coffee is freshly brewed, filling your nostrils with wonderful aromas. Ping! It's your manager. We need to speak. Let's get on a huddle. So you get on a huddle with your manager, and your manager tells you that she has just got off a call with the CTO, and the CTO wants you to work on the new high priority project for your business. What is that? The CTO wants you to build a full stack to-do application, the world's most adopted to-do application. It has to serve both mobile and web users. It has to be robustly tested before being deployed into production. And best of all, you've got 2 weeks to launch it. Ah, great. There goes my nice Monday morning. How would you deal with this? I want you to sit and think, if you were given this task by your manager, how would you actually go about it? Well, let's think about it. You're a developer, right? You would probably start by building the code. You might build that front end. And let's be honest, for a lot of developers here, building a to-do application is probably pretty simple. And then you might be capable of adding the back end yourself, or you might go to one of your full stack engineer or back-end engineer colleagues, and they would build the back end, or you would build the back end, and you deploy to your dev environment, and you try things out. It seems to be working all right, so great. I'm then going to test. I'm going to see if it's working on Firefox, on Chrome. I'm going to see if it's working across maybe a couple of my mobile devices. Amazing. It seems to be working all right. So I'm going to deploy to prod. And there are no bugs. It's all working pretty seamlessly. Let's launch it. Happy users. I don't know why we're in such a panic. That's actually really easy when we think about it, right? But what about all this? What about the way that you build the UI components? What about the way that you choose an API that allows your front end and your back end to communicate? Or we talked about deploying to dev and deploying to prod, and that involves creating an entire CI/CD pipeline. And what about serving your users? You have to choose a content delivery network, you have to set it up, and again, all of these decisions have wide-ranging implications for your application and add a lot of complexity, and ultimately take time away from you doing what you do best, writing great code. And that's where AWS Amplify came in. Because simply put, we built AWS Amplify to make it easier for developers to build full stack applications. Think about all of that complexity that we just talked about. Amplify abstracts a lot of that complexity away from you. So it allows you to build and host a front end. It allows you to add features like authentication and like storage, and to deploy and scale to millions of users. So with Amplify, you can develop, you can ship, you can scale your application with just a few lines of code. And it doesn't matter whether you are building a web application. Here are some of the frameworks that are supported out of the box, whether you build using React or Next.js or Vue or Nuxt.js. Or if you're building a mobile application, for example, for Android or for iOS using Swift. And this is not an exhaustive list, by the way. There's plenty more. This is to say that some of these very popular frameworks are supported out of the box. Great, you say, okay, but how does it actually work under the hood? Well, let's look at that. With Amplify, we start with you, the developer. The developer is at the center of this service. And you're a developer, you've built your basic application, you're likely to be hosting that on your local host, but you need to serve users outside of there. You need to serve users around the world. So that's where Amplify hosting comes in. And Amplify hosting is a fully managed CI/CD hosting service. Allows you to build fast, secure, reliable, static, and server-side rendered apps that scale with your users. Again, thinking about that brief that your manager gave you. Okay, but before you even think about hosting the application, you've got to build it, right? So that's where the app front-end features of Amplify come in. And we talked about some of the frameworks that are supported. We also have UI components. So rather than doing a lot of that heavy lifting of building UI components, say that you wanted to add, for example, a login UI to your application, a lot of these are available out of the box with Amplify. On top of that, we then have the Amplify libraries. And these are open source libraries that allow you to connect with an AWS backend to offer features like authentication, like data, like storage. And if you're the type of developer who likes to build your UIs visually using Figma, we've actually worked directly with the Figma team to create an Amplify plugin. So from directly within the Figma console, you can generate clean React code that you can integrate with your Amplify applications. And then you've got your backend on top of that. And we talked about the Amplify libraries from a backend perspective. These same Amplify libraries allow you to add these components. And if we think about what's actually happening here, with Amplify, rather than having to go into the console and create an Amazon Cognito user pool for authentication, Or rather than having to create a DynamoDB table for your database persistence, or having to create an AppSync API, you can do all of this using Amplify, which orchestrates and creates these resources under the hood. And while historically, you might have done a lot of this back-end, say, data schema building or back-end orchestration using the Amplify command line interface, I'm really excited to share with you, for those who aren't aware, that as of November last year, we've introduced in preview a new code-first app building experience in the form of Amplify Gen 2. And what this means is that we are putting the developer even more at the forefront of the Amplify experience. So Amplify Gen 2 now allows developers to express app requirements like data models, like business logic, like authorization rules, but all using the TypeScript programming language. So you will build your backend code in TypeScript, and you can import those components, you can import that backend using your front end. And just to touch on some of the features that we're introducing here, again, it's TypeScript first file-based approach. So when you add Amplify to your project, you're actually adding Amplify scaffolding into your project folder. An entire Amplify folder will be added. Within that, you can then define your backend resources like auth, like data, but using TypeScript. And all of this is built on top of the AWS Cloud Development Kit, or AWS CDK, which is an infrastructure as code service. Now, what this means is that you can now integrate any AWS service with your wider Amplify project. And that means the limits of building on Amplify are now pretty much endless. And we'll touch on some of these other features later on. But for now, I really want to talk about how you take a front end that you've built and how you would host that front end so that you can serve your users. So what we've got here, we've got a very simple AWS Summit London to-do app. And what this allows me to do is I can go in and I can add a to-do. So I'm going to add in the most important to-do that I have today, which is fill in the survey for this session. I can add that task. I can complete it if I want to. I can undo that completion, and I can delete it. So very simple, right? And look, as a developer, this is probably really simple for a lot of people to build. They could do it with their eyes closed. But I want to draw to your attention two things. Number one, we're running this in localhost, okay? So this is just running on my local machine. And if we think about that brief that your manager gave you, this isn't really meeting it. We need to serve millions of users across the world. And then the second thing I want you to bear in mind is, as a developer, I like using source control tools. So I have actually connected this up to a GitHub repository in the back end. So it's running on a GitHub repository. If I change to my terminal and I run git status, you'll see that this is actually running on the dev branch. So I've already pushed my changes up to GitHub. Okay, great. How would we actually host this application? I would go to my AWS console, and I would go to AWS Amplify, and in the top right, you will see this new Amplify Gen 2 experience, so I'm going to select that, and then I can either start with a new app. I'm not going to do that because I've already built my application. I am going to start with an existing app, which is actually built on top of the React framework. I've got 3 steps. The first step is to add Amplify backend features to my project. Now, I don't actually want to add a back end, but I would like to have the option to add it. I just want to host the front end code for now. But to give myself that option in future, I am going to run this npm create amplify command. I'd actually recommend running npm create amplify at latest. So I'll run this. I'm in my project folder at the moment, running npm create amplify. And what that is going to do, if I jump to my IDE, we talked about this Amplify folder. If we look in the top left of my project, what this has done is added that Amplify scaffolding to my project. So if I want to add auth, if I want to add data, I can do that all here, but I'm not actually going to for the time being. It just gives me the option. So I'm actually going to completely skip option 2. I don't want a data model right now. And step 3 is then just to push to my preferred GitHub provider, to my preferred Git provider. So I've already pushed the changes to Git. I'll select next, this is the first time doing this, I'd add my GitHub credentials. I can select my AWS Summit London project, and I can select the dev branch that I am running on, and I've pushed my changes to. I'll click Next. You see it's got that Amplify Gen 2. It's auto-detected that that Amplify scaffolding is in my project, and then I'll click Save and Deploy. This takes 4, maybe 5 minutes max to deploy, so I'm going to jump to another region where I've already done this. And you'll see I've now got an AWS Summit London 2024 project. It is now hosted. If I look at my dev branch, I have got a domain that has been created for me. Of course, I can customize that domain if I want to, but for the purposes of serving millions of users around the world, I can do that now. So I'm pretty much ready to go, right? If we think about that brief from my manager, I can add fill in survey, and I can say that it's ready. The only thing is, what would happen if I refresh the page? Okay, the to-do has disappeared. Why is that? Why has the to-do disappeared? Well, of course, if we think about it, I've just got a front end, right? There's no way for that data to be persisted at the moment. So I'm wondering if my colleague Ozzy might be able to share a bit more about how we would add a backend to that front end. So over to you, Ozzy.
Thank you so much, Fred. So over the past couple of minutes, Fred just showed you all how you can get started with hosting your front end on AWS Amplify. So in this section, what I'm going to do is to take you through how you can begin to layer on cloud functionalities to add a backend to your application, and also some of the new features we've launched on AWS Amplify Gen 2 that will transform developer experience and also help you to accelerate your time to market. So let's go back to our to-do app. So here are some of the backend components that we can think about adding to our to-do app. For example, we can add authentication to manage user accounts and permission, to enable your users to log in and create their managed to-dos. And also you can think about adding that data layer, that persistence layer. And this will involve providing an API so that from your front end, you can create, you can read, you can update, you can delete to-dos, but also provide a persistence layer to also store your to-do data as well. And then you can also think about adding storage. For example, you might want to provide a functionality where users can take a picture when they complete a to-do and upload that as well. And many more. Think about things you can do with AI, for example, summarizing the to-do for the day, or potentially even sending a notification as a reminder to the user, for example. So with Amplify Gen 2, we're really making it easy for you to layer on this cloud functionality. And you can do that by running this command, npm create amplify at latest, and this will do two things. So the first thing it's going to do is to install the Amplify dependencies within your project and not globally your local machine. And this is really important for developers because we've gotten a lot of feedback around this. It helps in project isolation to make sure the libraries are all within the projects you are working on. The second thing this will do, like you saw previously, is to really set up almost like a scaffolding for you to start implementing your backend. So with that Amplify folder you see at the top, we provide the auth and data scaffolding to help you to easily implement authentication and also the data layer within your application. And for services we don't support natively on AWS Amplify, you can easily incrementally extend your backend using the Cloud Development Kit. But I want to dive a bit deeper into that auth and data backend, which is typically where you get started. So within Amplify, we'll provide you a way to easily create your user directories and also federated identities. And under the hood, we'll create with a service called Amazon Cognito, or will power this functionality without you having to really understand the intricacies of how to configure Amazon Cognito. And then for data, you basically define your schema, and you'll see this shortly in the demo as well, where you define the schema of your to-do app. And under the hood, we'll leverage a service called AWS AppSync, which is a managed GraphQL service, to create the APIs for that schema, but also set up the database layer with DynamoDB to enable you to store that data as well. And once you set this up, you'll be able to invoke your APIs from your front end or to implement authentication features from your front end as well. And like I mentioned before, you can also connect to other AWS services beyond what we natively support on Amplify. And you can do this with CDK. So one of the files we provide for you when you set up that scaffolding is really the backend.ts file. This contains all the backend components for your application. And you can see the auth and data backend as well. But for example, assuming I want to implement like queue functionalities within my to-do app, or some sort of a notification within the to-do app, what I can do as well is to import those libraries from CDK. So this will give me the capability to be able to create the resources to enable me to consume or to leverage these functionalities within my application. So once I install the libraries, I'll be able to define a stack to create those resources within my backend. And once I set this up, you should be able to integrate with your front end to consume these services as well. Before I dive into the demo to kind of show you how you begin to add this backend, I want to take you through that we're not just making it easy for you to add those cloud functionalities, we are also transforming the way you deploy your code changes to the cloud, and also helping you to think about your developer experience to rapidly improve that. And I'll show you 3 ways we are supporting that down on AWS Amplify. So the first one is around developer sandboxes. So when developers are typically working as a team, each developer will typically want an isolated environment where they can build, test their functionalities with real AWS resources. So what we've done with Amplify Gen 2 is we've provided you the capability for each developer to create their own individual cloud sandboxes where they can test, iterate on their code, and once they are happy they've built their functionality, they can delete their sandbox and commit the code to the central repository. If you're like me, I don't like waiting for my code changes to be deployed in the cloud. Sometimes it can take minutes, sometimes it can take even a bit longer. And this is something we are trying to solve with the sandbox capability we have on Amplify Gen 2. So once you set up a sandbox environment, say a developer set up a sandbox environment, what basically happens is we'll monitor all the backend changes within your backend files. So Sandbox will be able to identify any changes once you save those files and automatically deploy those changes to the cloud. Let's take, for example, you want to add a database table, say for a to-do database, where you have already defined the schema for your to-do within the backend files. Once you save that file, the sandbox set up within your coding environment should be able to pick that up, pick those changes up, and automatically deploy that to the cloud within seconds. And we support this as well for a range of other changes you might want to make on your backend, both changing of a field or implementing new authorization rules as well. And the final feature I want to talk to you about is really what we call full stack branch deployment. So with Amplify Gen 2, we are enabling you to automatically now deploy your infrastructure and application code changes from a feature branch to an isolated staging environment. And this is really important because when you are deving, when you are building a new feature into your application, you want to be able to test those features in an isolated environment. And once you are happy with those features or those changes, you can merge that to the main branch and deploy to production. And we are enabling you to do that, to automate this workflow end-to-end with AWS Amplify. So to kind of show you some of these features, I want to dive deep into the demo to kind of show you how some of these things work. So let's go back to our to-do app. So here is the to-do app we earlier talked about. And you can see that this is still running within the local host environment. So the first thing we are going to do is to really set up that cloud sandbox, which is really important because we want to be able to have an environment where we can dev and test around. Now you can see the cloud bus. Once you run the cloud bus, the sandbox command, that will set up the cloud sandbox within your local environment. And one of the key things you see there is waiting for any file changes you make to your backend file, and it will automatically pick that and deploy to cloud environment. So we go back to our front-end app. So here is the front-end part of our app. But for the purpose of this demo, I want to focus on the back-end side, which is where we'll be making some changes. And so you see how this will flow to the cloud as well. So what I want to do now is to dive a bit deep into the to-do schema. So we have our to-do schema here, just highlighted. You can see this is where I'm defining the fields for the to-do schema. So I'm specifying the content, which will indicate the contents for the to-do. And also, I can decide to add a new field. For example, say I want to add a field to represent when the to-do is completed. So I'll put a done field now, which will be a Boolean to say whether the to-do is completed or not. Let's leave it at these two fields just for demo purposes. Okay? And now once you define that, what you can begin to do in your front end as well is to begin to import that schema and consume some of those APIs that will be built for you under the hood. So things like creating a to-do or updating a to-do. And once I save this file, look at what's going to happen. The sandbox will be able to pick those changes and automatically start deploying that to the cloud without me doing anything. So this will take a bit of time. Within seconds, those changes will be deployed to the cloud. And you can begin to test those changes now within your front end to see how that reflects as well. So what I'm going to do now is to commit those changes I've just done to the backend now to my Git repository. So I'll run a couple of Git commands to get that up there. So we'll basically push these changes to our main branch. And once this pushes to the main branch, what I expect to happen is this will automatically start deploying to Amplify. Given that from the previous demo, you can see that that repository is already linked to our Amplify project in the cloud. So you can see that deploying now within our main branch. And once it's deployed within a couple of seconds, you should be able to navigate to the link generated for you by Amplify. Of course, you can also customize this link to a custom URL and begin to try out, test out the app. You can see now I can fill in a survey, which is the most important task for everybody in the room today. And once I refresh the browser now, you can see that that's more persistent. That's not disappearing anymore. So what this have done under the hood is to provide the APIs to be able to create the to-do, but also store that in a DynamoDB as well. And you can see I can use that new functionality I talked about, the done field, to be able to mark the to-do as done, all driven via the API that is created for you under the hood, and also stored within DynamoDB as well. So I think the key point to mention here is that we don't only support this for web browsers as well. You can also do this for your mobile application. So whether you are running Android, Swift, or Flutter, you can use the same steps to add cloud backends to your application. So you start with that npm create amplify latest to set up that scaffolding for your backend. And then you can also use the sandbox to iterate locally and then commit your changes to the cloud once you're done. And I'll recommend you, if you want to learn a bit more about how to build this for mobile, scan this QR code. We have some code snippets to help you to get started with that as well. So a quick recap of where we are, where we've gotten up to. We've shown you how to host your front end on Amplify. We've shown you how to begin to layer on cloud functionality and how to deploy to dev as well. If you think about it, we are almost ready to go to production. We're almost ready to tell our manager, our task is completed, we are good to go. But before you do that, you want to make sure that you've actually tested your application across multiple mobile devices and different browsers that probably represents what your client will use to access your to-do app. But how do you achieve that testing? There are different types of testing, but the testing I want to focus on here is called the application testing. So this is where you test your web and mobile app for functionalities, for usability, and also for compatibility. But you are doing that on real mobile devices and also on real web browsers as well. But we know that this is challenging for a number of reasons. We see that a number of new mobile devices coming up almost on a regular basis from different manufacturers, different OS versions as well. And what we typically see some customers do is to actually go and try and build a device lab on-prem, go buy some phones and build a device lab on-prem. But we know that this is not scalable, and there's a lot of heavy lifting to make sure that they are properly updated and they are properly powered on as well. And if you think about it, for our to-do app, we need to go 2 weeks live for our to-do app. This is not an option for us. And of course, how do you also understand where the bugs are? How do you build a good reporting mechanism to understand where the bugs are, where your tests are passing or failing, and also to be able to pinpoint and fix those before you go to production? And that's really why we build AWS Device Farm. So AWS Device Farm is a managed service that will help you to improve the quality of your mobile and web application by testing it on real devices and also on web browsers hosted on AWS Cloud. There are many features of AWS Device Farm, but I want to focus on these core three. So the first is that Device Farm enables you to do what we call automated testing. So this is where you test your mobile application, your native mobile application on real mobile devices, and you can test that in parallel as well. The second feature I want to highlight is what we call remote access. So with remote access, you select a particular device, the manufacturer, and Device Farm will display the screen of the device right on the browser. And we see customers use the remote access feature when probably they want to replicate an issue that the customer have reported on about the mobile app, or when they have a new feature they want to test and see how that works on the app as well. And finally, desktop browser testing. So this is for your Selenium-based tests, where you can basically, Device Farm can provide you a Selenium grid endpoint which you can configure on your Selenium tests to be able to run the tests within the cloud environment as well. Before I dive into the demo of Device Farm, I want to kind of dive a little bit into the automated testing for mobile apps to show you how this works. So you need two things to get started. You bring your app, which can be your Android or your iOS app, and then the test pack. And this test pack could be written in any of the frameworks we support, like Appium, Calabash, Espresso, and any other custom framework. And the configuration as well for your tests. You deploy that to AWS Device Farm. And once you initiate your test run, what we'll do under the hood is to spin up EC2 Linux if you are testing your Android apps, or EC2 Mac if you are testing iOS app. And this will orchestrate the test on real mobile devices. And once the test completes, we'll generate the test results and show you the devices, the tests that passed, and the tests that failed as well. So let's go back to our To-Do app. This is the mobile version of our To-Do app. We want to be able to test our app before we go live. So we want to test it on Device Farm. So we need two things. We need our app, which is our Android app, and then our test pack that we've already written in appium.js. So let's go through and show you how you can test that app now on AWS Device Farm. So the first thing you do is that you navigate to the AWS console and you just type out Device Farm to bring up the Device Farm service. Once you go up there, you see a concept of project that is a container of your tests. I've already created one here called London Summit, which once you open that, you see a number, your test history. But what we're going to do is to create a new test run. We want to start a new test. So the first thing you do when you're starting a new test is to upload the app. So those are the first thing you need. So I already have a sample app here I've uploaded. You can quickly change that to, we call it a to-do app. That's the name of our app. And then we move on to configure the test framework. So here we are using Appium as our test framework, but you can use any of the test frameworks that are supported by Device Farm, just like you saw. So I've already written this test pack in a zip file as well. And the next thing you do is to kind of put in the configuration of how your tests run. So this is where you have the capability to specify things to happen before the test runs and also after the test runs. And you do that in a bash script. So we'll create a simple config file here. You can also use the default that is already created for you to get started. Give it a name, and then create the config file. So that's pretty much what we need to get this test running. There are other features you can set up as well, but those are not mandatory. For example, setting up your device pool. So we provide you a device pool to run your test on, but you can also create your own device pool where you select the mobile devices you want your test to be run on. And then you go to next. This is where you put in additional information, like if you need other softwares for your application to run, if your app needs other softwares to run in parallel with it, or if you want to kind of test different network conditions, like put on Wi-Fi on the mobile device, or test different network profiles as well. That's basically the configuration we need, and you start the test run. But I've already done this test, so I'll kind of show you a completed test of what it looks like. So once you go there, this is an example of a completed test. You'll be able to see for each of the mobile devices how the tests ran. So for each of the mobile devices, you'll be able to go into there, click on the test, the video to show you the test actually running on the mobile device. And you'll also be able to see the logs at the back of the test as well. So the test specification logs and the logs that gives you information about the errors or the infos as well, so that you'll be able to begin to pinpoint when things might be going wrong as well. And remember, with Device Farm, you don't only do mobile app testing. So the web app we built as well, you can test that on Device Farm. You can see the desktop browser testing by the left menu as well. And once you set that up, you can begin to run your web browser testings as well using Device Farm. Customers of all sizes are already building on AWS Amplify. For example, Amazon Music is using AWS Amplify and AppSync to sync the playlist of millions of their customers to be able to allow them to play music offline. But I think I want to talk about this interesting customer called Busby. So Busby have built an app that can detect cycling or any sports-related incidents and be able to send the location of that incident to emergency contacts. Using Amplify, they were able to go build an MVP within 3 months and was able to expose that to their cyclists and also use it as a way to secure investment from their investors as well. And I like this quote from the co-founder, Kik Ryan, that says that using Amplify have enabled them to save 6 months worth of development time, but also $100,000 in outside development costs. Think about what that means for a startup like Busby. So if you think about it, we've tested our app. It looks like we are ready to go live. We're ready to go tell our manager that we are ready to click the go live button and expose this wonderful app to all our users. What do you think, Fred? Are we good to go? I'll hand over to my friend to wrap you up.
Jose? Are we good to go? Are we good to launch our to-do application? It's a good question. Let's think back to that Monday morning. Let's think back to earlier in this talk when your manager reached out to you, the panic that you felt when you realized that you had 2 weeks to build an application, the world's most adopted to-do application. Well, here's the good news. Much as it felt like panic at that point, you now all know how to do this on AWS. Every single one of you could take that idea and put it into practice. We showed you how to build a front end and host that using Amplify hosting. And we showed you how to then add a backend to that front end using the new Amplify Gen 2 experience and all of the other AWS services that orchestrates under the hood. And we showed you how you can then test that application robustly across different mobile devices or across different desktop browsers using AWS Device Farm. So, are we ready to launch this app? You bet that we are ready to launch this app. Let's do it. It can now serve millions of users across the world. And you know what? I think that is pretty cool. But I don't want you to stop there. Think about it. In the grand scheme of things, a to-do application is very simple. But Amplify, it is powerful enough to allow you to build fully featured, rich applications. And I can't wait to see all of the amazing things that you go away and build for your users and for your customers. There are a ton of resources to help you go away and do that. But what Ozzy and I have done, we have condensed that into what we think are the 3 most essential resources to dive into. So please do take a photo, scan the QR codes, and whether it's on your journey home this evening, whether it's back at your desk tomorrow morning, I want you to go and read more about the things that we talked about today. And if you want to dive even deeper and learn more about AWS Amplify and AWS Device Farm and all the other services that we talked about today, I'd really encourage you to redeem your free trial of AWS Skill Builder. Join the millions of people around the world who are upskilling themselves continuously on the cloud. And we really, really hope that you enjoyed today's session. We really do. But you know what? There's only one way that we can find out if you did, and that is by completing your most important to-do of the day and fill in our survey. So if you scan this QR code, it will take you directly to this session on the app. Folks, I'm Fred, this is Ozzy, and today we have showed you how to build and deploy a full stack web or mobile application on AWS. Thank you very much.
Thank you.